Welcome, everybody. Thanks for joining today. My name's Jennifer Griffith, and I work at NUMOA, which is the Northeast Waste Management Officials Association. We are an interstate association formed by the governors of the 6 New England states back in the 1980s to deal with waste issues. So solid waste, hazardous waste, the toxic use reduction and pollution prevention programs, and then also the waste site cleanup programs in the 6 New England states, and then New York and New Jersey also joined NUMOA. So we are the 8 Northeast states, and those programs are part of NUMOA. And the main priority for the waste site cleanup programs is training. So that's what we're doing here today. So we've got 2 great presenters, Duncan Pfaehler and Yurlina from Maine, who are going to talk to us about their efforts with the agricultural sector. Maine really is a leader here in our region on helping farmers and dealing with some of the agricultural impacts with PFAS. So I think I'm showing the NUMOA website. Duncan and Mary, do you see the NUMOA website?
Yes.
All right. So I just am showing this because we are going to be getting PDFs of the presentations and posting them on the NUMOA website after the webinar. And so I just want to show you where you can find information about NUMOA's future and also past events. So you go to the NUMOA website, NUMOA.org, you click on events. My computer might be a little slow. I have to apologize for that. And let's see. Okay. So the website is very future oriented. So it's got all the upcoming webinars. There's 2 more after today in this series, background studies, and then also PFAS investigating in wastewater and septic systems as the source. So those are both happening in December. And but if you want to go to past events, which today's webinar will be past in a little bit, you have to, this little arrow is really key here, this backwards arrow here. So if you go there, then once my computer finishes, it will show you all the past events, and they go reverse chronologically. So as many as fit on the screen, like you can keep going past even further back. But so the whole series we've done so far is up here now. So we started back in August with 2 emerging issues, PFAS oh, we did basics even before that. Where did that go? Well, I guess it didn't fit. So all the other ones that we've done, but also all of NUMOA's webinars that are here. But you can see, I'll look at like this thermal treatment one here. You open that up, then it's got the PDFs linked here and also recording. So that's just to let you guys know where you can find information about the webinar afterwards, as well as other webinars that NUMOA has held. So let me, there's a couple more things. So again, we'll be posting PDFs of the presentations on the NUMOA website. I'll send an email around to everybody when that's happened. We are offering Massachusetts licensed site professional continuing ed credits for these webinars. So if you do want the Massachusetts LSP continuing ed credits, so that's the only kind of credits we're giving, is you need to do a few things. One is to stay on the webinar, till 3, be on it the whole time. Just in case everybody doesn't know, GoToWebinar can tell if you are doing something else on your computer and not just having the webinar at the top. If you do want those Massachusetts LSP credits, you need to not be doing, you can't be sending emails or checking emails or doing visiting other websites or anything. You need to keep this webinar at the top of your computer the whole time. as well as there are going to be some poll questions during the webinar. And if you want those credits, you need to be answering all the poll questions. And then if you could type in a question at some point as well. So we do have a lot of folks attending today, so we will be doing questions. You'll have to write them in. So everybody has their own GoToWebinar control panel, and there is a questions section there that you can open up and then type in questions. I will be looking at those and then asking the presenters the questions during the Q&A time. So you can type in questions at any point. So I think that's all the logistical stuff that I have. So I'm going to turn it over. We're going to start with Mary, who's going to give us an overview of the program. So I'll make her the presenter and I'll introduce her. So Mary Yurlina is a field ecologist by nature and by training who has been active in Maine's agricultural sector since 2001. She started working for Maine Department of Agriculture, Conservation and Forestry in their PFAS response program in the summer of 2022. She earned her PhD in ecology and evolution from Rutgers University and has her bachelor's in conservation and applied ecology also from Rutgers. So with that, Mary, take it away.
All right, I'm going to shut down my video and show my screen. Okay. All right, is that working?
Yes, there we go. Okay, I'm going to mute myself.
Great.
Take it away, Mary.
Okie dokie. All right. So, yeah, I am an agricultural PFAS specialist with the Department of Agriculture, and there are 3 of us agricultural specialists who go out in Maine and work directly with farmers and take samples. I'll talk more about our program in a moment. So I was assured that you guys are top shelf PFAS experts. I don't need to describe what constitutes per and polyfluoroalkyl substances. I guess I'll just mention that Maine statute defines PFAS as the class of fluorinated organic chemicals that contain at least 1 fully fluorinated carbon atom. And there's lots of things that have PFAS. We all know where PFAS comes from and how it gets into farm fields and agriculture. And I think we all know that PFAS is linked to a wide variety of health impacts at this point, which is kind of concerning. And that is why we want to keep PFAS out of the food supply. So I'm going to give you guys a brief timeline of Maine's response to PFAS contaminated soils. Largely that arose from the land spreading of sludge and biosolids in the 70s, 80s, 90s, 2000s. So back in 2016, we discovered an impacted dairy farm. I actually think it was the water treatment plant in a southern Maine town that was monitoring a well on this farm because they had been spreading biosolids there and discovered high levels of PFAS and alerted the state about it. And then the state tested the milk and found high levels of PFAS in the milk, which was very concerning. And that led to the development of an action level for the state of Maine for PFOS in milk of 210 parts per trillion. So we do parts per trillion in liquids and parts per billion in solid agricultural products. So if we were to test a milk product and it came out above 210, we would consider that milk adulterated and we would put a stop sale on that milk product. That's what that means. In 2019, Governor Mills created the PFAS task force. The state realized that lots of agricultural lands had biosolids and sludge spread on it, and this was something we needed to investigate farther. Recommendations regarding safe drinking water and food and identifying and investigating PFAS in the environment were all spelled out in this document. In 2020, retail milk testing identified a second dairy with high PFOS, and also a third dairy was discovered soon thereafter. We hopefully all realize that when you're producing milk, you are also producing beef critters. So beef was also sampled on at one of these dairies and discovered high levels of PFAS in the beef, and we had a PFAS action level developed for beef as a result, and that is 3.4 parts per billion. So those are the only two regulatory action levels that Maine has right now, is for milk and for beef. Around the year 2019, 2020, a public-facing map of all the sludge and biosolid sites. These are the licensed sites. It's certainly possible that unlicensed products have been spread out there too, but these are the licensed sites for biosolid spreadings. Was available to the public, so you could go and search around the state and see where these sites were located. And you know, farmers and consumers started looking at this thing, and soon you know, there was some self-testing that was done. Folks contacting the state about whether or not their land was impacted, and during this time we had some other local farms discovered that they had some very considerable PFAS contamination on their farmland. So this is sort of the background, and that was back in 2021, 2022. So in 2021, the legislature of Maine approved a budget for a multi-agency response. It's mandated that the Maine Department of Environmental Protection go and sample all of these licensed sites throughout the state with landowner permission. They do ask. Sampling the soil on these sites, and they also sampled groundwater on the sites, and also at certain distances outside of the sites to see if there's any groundwater contamination. In 2022, the Department of Agriculture, Conservation and Forestry started assembling a PFAS response team, and of which myself and Duncan are a part of that team. There's, I think, 7 of us now. And the state Department of Agriculture, Conservation and Forestry also set up this PFAS fund, sort of this another entity dealing primarily with providing financial support to impacted farmers around the states. In 2022, there was a ban on the land application of sludge, so that's not allowed anymore in the states. The PFAS fund plan was finalized in 2023. The state gave that $60 million to work with. By 2024, roughly half of all the licensed application sites were completed by the Department of Environmental Protection, and their goal is to get them all done by next year. So they are working hard on that. There are 7,600 farms in Maine, but it's important to realize the vast majority are likely not impacted. And it's also worth noting that this is not just a Maine issue. Biosolid sludge is a fertility product that has been used all over the country, all over the world. So this is not a Maine thing. So tackling this PFAS issue is a multi-agency approach. Department of Agriculture, Conservation and Forestry, we work directly with commercial farms. We have a pretty broad definition of what constitutes a commercial farm. Basically, your gross income is $2,000 a year from the sale of farm products. We conduct sampling of farm products, soil, irrigation water. I would say that soil testing is probably our number one medium that we sample the most. That's where you start. That's the foundation, is the soil. We regulate acceptable concentrations of PFAS in farm products, as I mentioned, those 2 action levels at the moment. And we also have a bunch of financial support programs. We want farmers to keep farming, and you know, if possible, to keep doing the type of farming that they've always done. If that's not possible, we want to help them pivot to some other form of production so that they can remain in place on their farmland doing agricultural production. The Maine Department of Environmental Protection, they, as I mentioned, are testing all of those licensed sludge and septic sites around the state, which includes the testing of home wells that are next to these licensed sites. They also monitor landfill leachate. We have the Maine Drinking Water Program. They're responsible for public drinking water supplies, and that includes testing them for PFAS. Maine CDC, they're kind of the brains behind the action levels and the screening levels for farm commodities, and analyzing those agronomic pathways, how the PFAS is moving from the soil and the water into agricultural products. And I'll just point out, we meet with the CDC PFAS experts weekly to discuss all of our latest lab reports and what we're recommending to farmers to sort of mitigate their impacts. And let's see, and they also work directly with individuals around the state, farmers and non-farmers. We have a lot of gardeners and homesteaders in Maine, and Maine CDC works with them on that. And we also have the Maine Inland Fisheries and Wildlife Department, and they deal with fish and deer and game, and they issue consumption advisories. And there was just one that was in the news recently for the town of Unity, an area that there is a consumption advisory for deer. All right, where are we right now? And this slide is a couple months old. So DEP has finished their tier 1 and tier 2 sampling. Basically, they have looked at all of these, they've divided the licensed sites in Maine into 4 tiers. Tier 1 and 2 had the greatest volume of sludge applied to fields. Tier 3, I don't have the breakdown. I think might be like 5,000 cubic yards. Anyway, so they've broken it down by overall volume of biosolids. So they're doing tier 3 now, and they're probably starting to look at the tier 4 sites. When DEP discovers that a licensed site is still farmland and used for the production of food, they contact DACF so that we can get involved. And very often we take over the sampling from that point on, because we might want to sample things a little differently than DEP. It's also possible for farmers to do their own testing outside of DEP's tier approach and contact DACF directly that way as well. So we've been working with probably over 150 farms at this point, including self-testers. Over 60 farms have at least one test that exceeds a screening level. Usually that's soil. And we use the metric of 6.8 parts per billion PFOS in soil as a screening level. And many of these food producers, farmers, can adjust what they're doing and continue with technical and financial support from the state. And we've had 4 farms that have ceased production entirely, and 3 farms that have significantly downsized as a result of the PFAS on their farm. All right, let me check the time here. All right, so we have a very farm-specific response. You have to have it, because PFAS, there's so many PFAS compounds, so many things affect how PFAS is exhibited. It impacts the type of production on the farm. There's so many different types of farms. So data is incredibly important, and taking lots of samples are an important part of what we do. And our goal is to, figure out where is this PFAS contamination coming from? What does it look like? Is it PFOS, PFOA, other compounds? And help farmers, eliminate that source, or at least limit it as much as they can, and produce products that are not considered a health risk to customers. We also provide technical and financial assistance. So And every farm is different. Animals can depurate, so if you have a herd of cattle that has contamination over time and on clean feed, that PFAS contamination can leave their bodies and they can produce milk and beef. Couple of little bullets there about how not all PFAS are the same. For instance, PFOA doesn't readily accumulate in beef. Don't know why, but PFOS does. And we've noticed that also there are some vegetables and crops that also don't accumulate various PFAS compounds. So the details do matter. This is some data from a farm that had a very contaminated groundwater supply, a lot of PFOA in this instance. And you know, can you just say, oh, all of the vegetables this farm is producing are no good? That's not true. There are crops that showed no ill effect, no accumulated PFAS compounds, and there are some crops that did. So again, the details are very, very important, and taking samples is very, very important. PFAS compounds transfer differently between different media. You can have a certain PFAS profile in soil, and then when you look at the PFAS profile in the forage crop growing in that soil, it can look very different. It's not a mirror reflection of the peaks and valleys of the PFAS compounds in the soil. And similarly, if you look at the livestock, the animal tissue or the milk from the critters eating the forage on that soil, you can also get another completely different PFAS profile. So it's fascinating, it's confounding. If folks like puzzles, PFAS is definitely the field to be in. Here's a slide that just shows the amount of sampling that we've engaged in 2022. That's kind of when our program was really sort of mostly fully staffed. Almost 1,400 samples were collected, a similar number in the following year, and I'm sure we're up there again this year. Most of those samples are soil. We did take a fair amount of plant samples and also some serum and plasma samples. All right, I thought I would cruise through a couple of, well, actually one producer sample, but here's an overview. So we had a beef producer. They had contaminated water in hay fields. So the strategy was with water, you can filter it. We provided clean feed. We recommended grazing and feeding strategies to help keep the animals with low accumulating PFAS in their tissues, and also timing it such that when they go to slaughter, they have been on clean feed and thus have the lowest amount of PFAS in their bodies at that time. We had a vegetable example as well. I think I just showed you the graph of that. Actually, that was the water contamination situation. The soils, which we did test, did not have much PFAS contamination. So, you know, sort of an immediate short-term solution is to truck in water. We have frac tanks that we rent and fill with clean water for some farms. Then filter systems were installed on the farms to provide clean water for irrigation and crop prep. And this farm also requested a greenhouse for year-round growing in a manner that can reduce water usage. So that made sense. And the state of Maine, helped make that happen. All right, looking at the time, I should probably cruise through this. So this is that beef example in a little more detail. You know, this was a farm, in this case, this was a DEP queued farm for us, I believe. I actually wasn't here at the time this came to the fore. But step one is to learn as much as you can about the producer's farm management. What are they producing? How are they doing it? You know, where does the feed come from? Do they produce it all? Do they buy in feed? Is it grass-fed? Are they organic? These things are all important. And to develop a sampling plan and a good rapport with the farmer. That is actually very important. As we start collecting data and lab reports, we sit down with our CDC colleagues and we analyze it and figure out what the strategy is. In this case, sometimes a first step is to get a piece of frozen ground beef, and we send that off, and we discovered there was some PFOS. It wasn't over our action level, which was great, but it was in there and cause for some concern. I think this happened in the wintertime. We sampled baleage. That's a scene of silage covered with snow. And I believe Duncan was the one coring those. That looked like a lot of fun. We also took biopsies from living beef critters and sent them off to the lab. This is a graph showing the muscle concentration of PFAS over time. We also had the idea that perhaps we should pair this data with blood serum samples over this same series with the same critters and see if there's a correlation, and lo and behold, there is. And that's great because it's a lot easier to take blood samples from living beef cattle than doing a biopsy, for sure. And you certainly don't want to rely on going to slaughterhouses at the time of slaughter to figure out if an animal is above or below an action level, because lab analyses take weeks, sometimes months. And what are you going to do with that carcass and those meat pieces in the meantime if you don't know what's in it? So it's fabulous to be able to look at blood serum and get an idea of what the concentration in the beef tissue is. And in this particular case, and let me just look at my notes because I'm jumping around a little bit here. So basically, this farm had clean pasture, but not so clean hay fields. So the management strategy that we recommended to the farmer, and the farmer has followed, is to slaughter in the fall or send the cattle off to auction, off to market in the fall, after pasturing on nice clean fields, relatively clean fields. So during those summer months, 3-4 months, the concentrations of PFAS, which it acquired from eating hay from the more contaminated hay fields, could be lower during that time. And that has been a winning strategy for this particular farm. And this is just a slide showing, so in early summer, we had higher blood serum PFOS levels, and 3 months later in September, those levels went down pretty nicely. All right, it is time for the poll question.
Excellent, thank you. So we'll do the first poll question. I will launch it now. This is going to go back into your memory from what Mary talked about earlier. Maine's action level for milk is, so you can pick one, and everybody can vote. Kind of fun. We'll leave the poll open for a little bit. You just click on the circle that you think the answer is. I'll let it go for a little bit longer. If you want the Massachusetts LSP continuing ed credits, you must answer the poll question. It's optional for everybody else. Leave it a few more seconds. All right, I'll close that. And let's see, I can share the results. So I believe the correct answer is the second one, the 210 ppt for PFAS. That's in the milk. Then this 3.4 ppb for PFAS, I believe that is the meat one. So, but yeah, she talked about all these different numbers. So there's a little bit of confusion, but the majority of people pick the correct answer. It really doesn't matter what the answer is, just that people do choose one. So with that, I will go back and Mary finish up.
All right. So, Jennifer, be honest with me. How many more minutes would you like me to talk? I'll set my my speed.
Yes, you have about 10 more minutes, five to 10.
All right, great. I'm going to cruise. Woo. All right. So, in addition to all of this technical sciencey stuff that we are engaged in, there is a lot of funding to help farmers stay in business, as I mentioned at the beginning. This is not my bailiwick. There are folks dedicated to this stuff, but I have a couple slides on it. And if you guys are in state government or something and you're interested how this all got set up in Maine, please shoot me an email and I will put you in touch with the appropriate people to talk to. You know, I mentioned, you know, the state bought a greenhouse. There it is in the picture for a farm to help them pivot in a way that they could maintain the income they need to stay in business, not use as much water. And that has worked out really well. So examples of like that. In the beef example I gave before, we did spend some money buying some clean feed for that farmer until we figured it all out. So that is a really good use of money. We also have an income replacement program. There are periods of time when the farm is unable. If you're over an action level and you can't ship milk or sell beef, you probably need some income to get through. So there's programs for that. More on financial
Hang
support.
on, Mary.
Yeah.
I'm just seeing the poll question, and I don't know why we're not seeing your screen because it does.
Oh, do I have to share again? All right.
Yeah, maybe.
Sharing. Pause.
Here, I'll take it back. My screen, and then now I'm going to give it back to you. And
okay.
Then maybe we.
And then what happens? Show my screen. I'm going to do show my screen.
Yeah.
How's that?
Okay, there we go. Now we got it back again. I don't know what happened there. Sorry, everybody. Go ahead, Mary.
Okay. All right. That's whoops. Now going. There we go. Oop, there we go. Okay. More money stuff. So 60 million has been set aside by the state of Maine for PFAS expenditures for farms, for DACF support of farmers. And then we also got like 5 million from USDA. We have this separate thing called the PFAS fund, which is administering a bunch of this stuff. They also are supporting some interesting research, like academic research. You could write a proposal, and so keep your eyes peeled for those opportunities from Maine. And there's also some health initiatives that are on the way, so that's good. Maine is also able to buy farms. If the farmer's like, look, I can't deal with this level of contamination, I want to sell out, there is a program for that. All right, here we go. Boop. All right, so I thought I would jump into some more interesting things we've been learning. And I will just say that the realm of PFAS is constantly changing. I mean, we've been collecting data for 2-3 years now. And sometimes we'll collect data that kind of reverses what the data we collected on that same thing a year ago. So just keep that in mind. It's a work in progress. One of the bigger projects that we engaged in, and again, this was a multi-agency approach, was how should the Department of Ag best sample farm fields? We had been doing it the DEP way. They do a 10-part composite on a field that's 10 to 30 acres in size, and that works for their goals. Their goals are to make a guess as to whether the groundwater is being contaminated, but this method wasn't necessarily working great for the Department of Ag folks, because we saw there was a bit of variation depending on where those 10 cores were taken, which are done kind of randomly out there. So this shows, okay, when the cores are in those locations in the first illustration, the PFAS was very low. Another sampler did other points and the PFAS was very high. That range is not really helpful for a farmer. 1 versus 25 parts per billion PFAS. So, and then if you look at some interesting, satellite images of how manure or sludge or any crop input gets spread by tractors. It's not a perfect process. It's not an even process. There are areas that are more heavily spread than others. So, an area that has 168 tons per acre of whatever of sludge laid on it, it's probably going to have higher PFAS in that section than elsewhere. So, how do you get a good field average? Last summer, what I did last summer, we had teams go out and we sampled fields and sampled them again using different grids. This is just an image of some of the equipment we use when we go out and sample soil. We did a 30 grid composite. This is the ISM method, and I am gonna have a brain fart as to what here we go. Incremental sampling methodology is what ISM stands for. So we did a 30 grid composite and a 15 grid composite. They also did we did discrete sampling and looked at each one of those samples. And what we have settled on, is that DACF, our field folks, myself, are now doing these 30 core composites when we go out and sample a field. And we don't really sample fields that are larger than 30 acres. If we have a field that's larger than 30 acres, then we break it into smaller chunks. We're doing these 30 cores and compositing those. And we try to do it in this grid-like fashion. There is a way to use GIS so that we can go out there with coordinates of very specific grid locations, but we haven't quite got that online yet this summer, but it is something that we will probably do next year. And hopefully those give some pretty good readings about the PFOS that are in the soil. All right, so some confounding and head-scratching things that we encountered earlier on in our program, 2022, 2023, we had a couple of goat dairies that we were working with, and we kept getting really wackadoodle lab analyses for milk samples, like crazy high numbers of PFOS, and then like low numbers, and it was all over the place, and it made no sense. We were working with a dairy that we couldn't figure out, like, where was the PFOS on this farm? It didn't seem to be in the soil or in the forage. Turns out that colic acid, which is related to cholesterol, is high in goat and sheep milk. And that was messing up the lab analysis, which I think was the isotope dilution method. And basically it was masking itself or masquerading as PFAS in the analysis. So that's why we got those high levels. And that was kind of an epiphany when that got figured out. So EPA method 1633 takes care of that. So basically for all our milk samples, we use that method. Another sort of vexing situation, and that is a photo of a hay field that has just been cut and tedded, is the fact that we often get hay, when we sample hay or hay bales or silage, we get a lot of non-detects, and we know that forage has PFAS, and it's coming from some land that has pretty good levels of PFAS. We also know on the other end of that equation that the animals eating that forage have PFAS in their milk or in their tissue. So what's going on there? And that's been a little frustrating. Is it how we are sampling those materials? Is it how the lab is processing the materials? So that's to be determined. Just a heads up that has been a little bit of a vexing situation. And farmers like to they want to test their hay. They're not satisfied with just the soil. Okay, what's in my hay? And they get pretty excited when they get a non-detect result back. So. But it's a little bit magical to believe that sometimes that your hay is clean. All right. So it's a little bit repetitive. So we have worked with, just like with the beef example, dairy herds. We've had a few farms whose milk was above the action level of 210 parts per trillion. How do we get that down? Deparation, again, you got to figure out where the PFAS is coming from, get them on clean feed. and you have to manage those exposure sources and make sure that the herds are using, you know, clean or low PFAS level fields. It is possible. Here's some data for a farm that we worked with, some pretty high PFOS in the milk initially. But again, on clean feed, those levels go down pretty rapidly. We did have a situation where the farm had a hay bunker, and in that corner of a hay bunker, there was a contaminated field that was harvested. And once they hit that section and fed it out, boop, the PFAS responded rather quickly in the milk. So that was a bummer, but we did figure out what that was all about. You know, once they stopped feeding that, the levels continued to go down, which was nice. Another little study we did, we looked at fresh heifers. So that's a heifer that is having its calf for the first time. Apparently it has a lot of PFAS in its liver or other organs. And when it has a calf for the first time, it lets a lot of that PFAS out in the fresh heifer milk, and that can also cause a bump in the PFAS in the milk tank, in the bulk tank. Here's a cross-section of that silo situation I was talking about. So, you know, again, it's about managing your farm. So in this case, there's maybe a field or two that has some PFAS. Don't put all of that PFAS hay in one corner. You want to, on the little layer cake on the right-hand side, make some thin layers. So you're evening it out. You're diluting the impact of the forage from those particular contaminated fields. It's a better scenario. Some other things we've kind of come up with. Corn snaplage is a good choice for fields that have high levels of PFOS. In general, we've noticed, or it appears that the grains are not accumulating PFOS. Corn, you know, other grains, it's in the plant, so it may be in the hay and the straw, but it's not in the actual corn kernel. And we have helped some farmers pivot to a corn snaplage harvest by buying them equipment to harvest their corn crop in that way. A recent paper that the CDC team and others at the DACF have just published talks about how second cut hay may have higher PFAS levels than first cut hay. What else? And I did already mention that there are some vegetables that we have been sampling that have low or basically non-detect PFAS, even though they are growing in ground that is contaminated and has detectable and sometimes considerable levels of PFAS in it. So it's all very interesting. Yeah. The tall fescue thing, like a half an hour before this talk, someone said, what is that about tall fescue? The commenter thought that actually he may have saw something to the opposite. But we did have some data that says actually that tall fescue may accumulate PFAS more than other grasses, but perhaps that's not true. We need more data. All right, I'm going to stop there. I'm sort of running out of speed and happy to take some questions.
Great. Well, there are a bunch, but we are going to be a little time limited here.
Yeah.
But I guess we should talk about one fundamental thing. So people have heard that maybe the big issue with the farms was not necessarily biosolids from wastewater treatment plants, but some paper mill sludge. Or are you finding that farms that took just regular old biosolids are also having issues?
Both. I mean, I think, yeah, there's many different types of inputs that contain biosolids. So some of it is coming from wastewater treatment plants. Some of it may come from paper mill. There's products that are wood ash. You know, wood ash is a popular way to increase your soil pH, but some biosolids have been mixed in with the wood ash. It's called slash. So all of these different materials can contain PFAS. The different generators. I'm guessing that my colleagues in DEP can probably make a good guess as to where potentially, what generator produces a soil PFAS profile is coming from, based on the type of PFAS compounds that come out in the lab report. Does that answer the question?
I think so.
Okay.
It's basically just, you can't assume because your field or your farmers didn't take paper mill sludge that their fields are fine. You really have to go out and look and sample. Sounds like.
Right. Yeah. No, I don't think we need to call out paper mills in particular. Sometimes they are contributing to a municipality's wastewater content. But I mean, even sites that have like non-industrial, just the general public septage will have PFAS. And I mean, we're all we all have PFAS in our homes, and we're all shedding PFAS materials in our household goods, and flushing it down the toilet. So even septage will contaminate land as well. So yeah.
And we'll be having a webinar about septic systems and domestic sources in December, so people can join in there. I'll ask one more question, and then we'll switch over to Duncan, and then we can come back to some of these. But do you think the new drinking water MCLs, the 4 PPT, is that going to cause your milk and beef threshold or action levels to change, you think, or?
I think our action levels are, I think all of these things are under scrutiny and can change in the future. So, yeah, that's all I'll say about that.
Okay,
it's an evolving situation. And I mean, the more EPA and FDA, put out their findings, that gives us more data to reconsider our action levels and perhaps change them going forward. So nothing is set in stone.
Okay, well, I guess we'll have to deal with one more fundamental thing, which is, so biosolids, all wastewater treatment plant sludges in Maine are banned from land application at this point. So where are they going, and how is that going? In the Department of Ag, we don't deal with that aspect. I believe they are going to landfills, certain landfills, and being treated to minimize their impact. So that's a good question for Maine DEP. And maybe at the end Duncan can chime in on some of these in case he's got better answers, which he may have. Lots of other questions, but we're going to switch over to Duncan. I will just say, as far as I know, it's just going for disposal. There is not some alternative use for the biosolids.
Right.
So
right. Yep.
And it has created some capacity challenges for sure in Maine.
Yes.
Okay, I'm going to switch over to Duncan here, and we'll come back to questions. And if people can stay on past 3, we can deal with some questions then as well. So let's see, Duncan, you're in presenter mode. Yeah. Okay, let me introduce Duncan, and then we also have to do a poll question. So Duncan is the senior planner for the PFAS response program at the Maine Department of Agriculture, Conservation, and Forestry. Duncan also serves as one of 3 agricultural PFAS specialists within the PFAS response program, collecting agricultural and environmental samples, communicating with farmers, and implementing mitigation strategies on PFAS-impacted farms. He received his Bachelor of Science degree in agricultural education at Clemson University and has professional experience in ornamental horticulture, controlled environment agriculture, dairy husbandry, and agricultural education. So he's done a lot and knows a lot. And now I'm going to switch over here to the poll question. This is just the second poll question. Hopefully it's easy based on what I just said. Where does Duncan work? the University of Maine, the Maine Department of Environmental Protection, the Maine Department of Agriculture, Conservation and Forestry, or the Maine Center for Disease Control, which is their Department of Health in Maine. So we'll just let everybody go for a little bit longer. And hopefully we won't have the screen showing problem again. Okay, so I will close that poll, and the answer, most people got that right. He's with the DACF. So with that, Duncan, take it away.
Great. Thank you very much, Jennifer. And thank you, Mary, for teeing me up nicely for to talk about specifically uptake of PFOS in vegetables on farms in Maine. So yes, I am a senior planner for the Maine PFAS response program. Prior to that, I was working with Mary doing similar field work, and I've been with the department since January of 2022, and yeah, I'm going to talk about a lot of the work that we've done in the past 3 years at the department. A lot of this work was done in coordination with the Maine CDC staff, as well as other DACF staff and Maine DEP staff. So this work is not just my own, it's a collaborative effort, as Mary emphasized, between our agencies, and something that I feel is really important to acknowledge. Can everyone see the screen? Or are we back? Are we still on the poll question? Hopefully not.
Nope, I can see your screen, so I think you're good.
Perfect. Yep. So once again, hoping that everyone's familiar with biosolids, that application as it applies to agriculture, and the discovery and now the issue of PFAS and finding PFAS in soils, especially agricultural soils where we're growing plants. So plants are taking up PFAS into their plant parts, and we are eating those plant parts, and therefore we are taking up PFAS. So if we're able to understand how the plants are taking up these compounds from the soil into their various plant parts, roots, shoots, stems, leaves, and fruit, we can better understand that impact on ourselves and also provide farmers with decision-making tools that can hopefully help them reduce the exposure of their products to PFAS. So how do we determine a plant transfer factor, or what exactly is a plant transfer factor? You might hear them called bioaccumulation factors in certain research as well. It's a very simple equation. We take the wet weight concentration from the plant or plant part, and we divide it by the dry weight concentration in the soil. The reason that we use wet weight is specific to vegetable crops. So that decision was made because we are eating vegetables with the water within them in most cases. We're not all drying our fruit and vegetables. We use the dry weight in soil because we want to understand the direct impact of those soil particles and not the pore spaces and the pore water in that soil. So that's why we use the dry weight. But it's a very simple equation that helps us derive that transfer factor. And we have found that different plant parts take up different concentrations of PFAS. It's something that Mary alluded to in her talk specific to corn. Maine CDC, DEP, and DACF have worked to segment various corn plants and looked at the concentrations within each part. And essentially, as you move from the stem and leaves up, especially in the corn plant, you see a decrease in the concentration of PFAS. So you can have a relatively high level of PFAS in the soil, and you can then test that grain from the corn and find virtually none or no detectable levels in that corn kernel. It is, of course, specific to the soil concentrations, but we've tested soils in the 300 to 400 parts per billion range and still found very low concentrations in the actual grain portion of the plant, of the corn plant. That's specific to corn and specific to PFAS. One reason, before I go on, that we are looking specifically at PFOS, which is that 8-carbon chain with a sulfonic acid functional group on the end. The reason that we look at that specifically is because in Maine, it is the compound that we see most frequently in soil. So it's the greatest contaminant of concern for us. We are branching into looking at other PFAS compounds, and that work is underway with the CDC as well as the University of Maine. So once we've established a transfer factor for a particular plant or a plant part, how do we determine when we should be concerned about a concentration in the soil? And in order to do that, we consult with our folks at the Maine CDC. As Mary said, we meet with them every week. They have plant action levels, and then they take that action level, they divide it by the transfer factor for that specific plant, and that gives them essentially a soil screening level. So that soil screening level is not a hard line in the sand. It is merely an indicator that we need to investigate further what is going on with that soil agriculturally. It does not mean that farm cannot grow anything on that soil. It does not mean that if there is a farm producing a crop on a soil above that level, that they will necessarily find concerning levels in the plants. I know that is rather confusing, but we will talk about the variability and all of the contributing factors for that variability later on in this talk. The action levels, I can show you if we have time, I can show you the derivation of some of those action levels. But essentially, it is a very conservative measure looking at the high-end consumption rate, generally in 90 or 90th percentile for the most at-risk group, which would be young children, generally 1 to 6 years old, to be most protective, or to be protective of most people. So we're looking at a very, very conservative estimate for that, or calculation for that plant action level. So once we have a transfer factor and we have an action level, then we can derive a soil level and begin to know when we need to investigate certain farms in more depth. And so we can do that for specific plants due to the data that we've gained, and I'll show you some of that in this presentation, and I'll also share some work, especially with perennial grasses that our folks have participated in. Some folks from CDC as well have published that data. So for growing lettuce, hypothetically, if we saw soil levels above 40 parts per billion, we would want to investigate that further. It doesn't mean that we would go to this farm and tell them they cannot produce lettuce. It merely means that we would want to conduct additional testing, perhaps measuring the concentrations in the actual lettuce that they're growing. But then you'll see for growing potatoes, a very different number. PFAS value, and then remember, this is the value in the soil, we would be looking at, we would want to look further if we saw soil levels 150 parts per billion or higher. We would consider that a relatively high soil concentration for PFOS. That's what we'd be looking for if we wanted to grow potatoes. So for different plants, these levels can vary widely, and for different plant parts as well, because we see those different concentrations. So how do we collect these samples? We do co-located sampling, and we generally do triplicates. So we're taking 3 samples of a given crop from 3 areas. We're harvesting generally in a 1-by-1 square plot. For certain plants, asparagus, we did 2-by-1, and then for green beans, we actually did 1 entire bush. If we're doing larger plants like fruit trees, we'll just do 1 tree and we'll take soil cores from around that tree. We'll collect all of the plant tissue as if it were being harvested for sale. So as you can see with this crop here, we're cutting it pretty close to the soil. If we were collecting something like hay, we would essentially pretend that we were a big mower and cut about 3 to 8 inches, depending on the mower height, from the soil surface. After we've collected all of the vegetative material, we then collect cores from within that 1-by-1 square, and we collect the soil there. We remove all of the biota from the soil, so any macrovertebrates, earthworms, bugs, things like that, as well as rocks, roots, and anything else that may potentially bias those results, because we really want to focus on just the soil concentrations here. We homogenize that and then send it to a lab. So I'll show you, we were working with one farm in particular in 2022 and 2023, where we saw a good variety of soil concentrations within a relatively small area, ranging from about 16 parts per billion PFOS to upwards of 40 parts per billion PFOS. You can see the acreages there next to the field numbers, as low as ½ an acre up to a little over 1 acre. So these are relatively small plots. We're not looking at, massive operations here. Relatively small farms in Maine is the norm. And you can see on your right there, the various crops that we collected for each year. So in 2022, we collected bok choy, lettuce, arugula, and kale. And then we were able to further sort of dive into the lettuces and really parse them apart by variety. In 2023, collected a second set of bok choy. You'll notice the crop rotation there. The bok choy did move, which meant we were working with a different soil concentration. We also then collected romaine lettuce, oak leaf green lettuce, incised green lettuce, and radicchio. We were hoping to collect additional samples during the 2024 season, but we learned that this particular farm was moving to a no-till system, and they were top dressing the contaminated soil in these plots with about 2 to 4 inches of compost. We did test that compost. It was non-detect in 2023. And we did see in some of those samples a lower uptake. I'll talk about that a little bit more, but for those reasons, we did not return to sample in 2024. I will note, I work for the Department of Agriculture for the state of Maine. We are not set up as a research institution, and so these samples were collected opportunistically as a way to provide technical advice to this individual grower. Since then, we've worked with several other farms and kind of been able to build somewhat of a data set to help further research at other institutions like UMaine. So we analyzed the soil and the plant tissue at different labs. We used PACE, or at that time Alpha, and used a 537.1. At that time, they were not running 1633. It had not been approved. I think it was approved in January of this year. We sent the plant tissue samples, the vegetative samples, to Battelle. We sent them to Battelle because they use a cryo grinder and they homogenate the samples really well. You can see in the photos below, that is a gallon bag full of lettuce. That is then in the second photo. It's a bit hard to see because it's on a very similar border or table, similarly colored table. After it's cryo ground, so it's frozen and then milled or ground up, it creates a very fine powder that is very well homogenated, and that's helpful because it reduces variability from one plant to the other. We also then sent this homogenate to the US FDA, who we have worked with for the past several years. They've used their proprietary method that I think, well, it's not proprietary, they published it, but it is a slightly different method than what Battelle has been using. And we did see similar results from those samples. Speaking of results, you can see them here. So the top left, you see the transfer factors by plant type for 2022. So that was the first year. And then the same data for 2023. I compiled all of the lettuce data together for 2023. I'll talk to you about that in just a minute. But you can see we saw, we did find detectable levels in the lettuce samples from 2022. The soil levels were ranging from 18 to about 19 parts per billion. For the bok choy, we did not get any detectable levels in the samples. Those soil levels ranged from about 12 to 18 parts per billion. And then with the arugula samples, we did see detectable levels, those soils ranging from 20 to 37 parts per billion. And we only saw a detectable level in one kale sample, and we averaged that with imputed values. Those soil levels ranged from 23 to 26 parts per billion. 2023 data is interesting, especially if you look at the two samples that we were able to collect for both 2022 and 2023. With those, in 23, we actually combined all of the detections. Those soil levels, we did see some detections, but it was much, much lower. We saw non-detects in a lot of those 2023 samples, even with soil levels varying from 16 to 32, almost 33 parts per billion. We were able to look at FDA was able to get lower detection limits for us, which gave us a lower transfer factor for the bok choy. The soils for the bok choy were ranging about 16 to 18 parts per billion. And then the radicchio was 21 to 23 parts per billion in the soil. So the bok choy agreed relatively well. But we saw an odd variation with the lettuce. We don't quite know why we saw such a decrease in uptake from 22 to 23, but it may be due to the fact that 2023, what we hypothesize is that 2022 was a very, very wet year for Maine. We saw a lot of precipitation, and perhaps that led to more mobilization of the PFOS into the shoots of the plant, or the leaves of the plant, excuse me. And then 2023 was a relatively normal year for rainfall. So looking at other vegetables that we have sampled, you can see various transfer factors, quite a spread. Looking at the arugula samples, we're looking at 20 to 40 parts per billion in the soil. That gives you an idea. For the carrot, that was only one sample. Like I said, we're not a research institution. We're just doing this opportunistically. That soil level is about 65. But then interestingly, if you go to the pepper sample, that pepper plant was sampled and the soil level was 337 parts per billion. So we were not able to detect, or we were able to detect very low quantities of PFOS in that sample, even with a soil level in the 300 parts per billion range. Looking at imputed values are values where we saw non-detect. We took half of the level of detection and used that as the plant concentration, and then took the value in the soil, and that's how we imputed these values. You can see asparagus, bok choy, corn, green bean, and rhubarb were sampled. The asparagus, we did go back and sample this a second round, so we now have, I believe, 12 samples of asparagus and have consistently gotten non-detects in every asparagus plant, despite the soil levels ranging from 165 parts per billion to 422 parts per billion, so an average of about 282 parts per billion, and still we were not able to detect PFAS in those asparagus shoots. So an interesting variability there. Time for the poll question.
Okay, so let's just launch this last one. True or false? Research suggests that PFAS concentrations remain the same throughout different plant parts, the roots, the stems, the leaves, etc. Is that true, that they remain the same, or false, that they remain the same? So, just let it go a little bit longer.
Jennifer, you need to play some Jeopardy music during this time.
If I can get, yeah, that's probably a little too much for me to decide. But yeah, so it looks like everybody pretty much is answering correctly. Doesn't really matter correctly, but the answer to that one, close it, I believe, is false. And I'm seeing your slides again, so I think we're good then. I think it works.
Excellent. And yes, that is correct. Research suggests that PFAS concentrations are quite different throughout different plant parts. So the answer is false. So as the Department of Ag, we are tasked with providing technical advice and practical applications for farmers to reduce or eliminate their exposure to PFAS in their food crops. So this is a very simple graphic that we use for farmers to, for vegetable farmers specifically, to give them an idea of where we are seeing the less risky versus the more risky vegetables. So you can see we have on the left side very little transfer, in the middle some transfer, and in the right column more transfer. These are still relatively low levels. You're seeing, greater than 5% transfer, but this is a good way that farmers can identify and assess risk on their farms. So some impact or some takeaways for impacted landowners. Certain crops are lower concern. I think I've hit that on the head pretty hard. But there are also management strategies that farmers can employ to reduce the effects of PFAS being taken up into their crop. So the location of their crop, if they have or are able to sample the soil for PFAS, they can identify areas on their farm where the concentrations in the soil are lower versus where they're higher. You saw in that grid sample that Mary showed, there can be hot spots in certain fields, and maybe those are areas that a farmer can potentially avoid planting certain crops. It's also possible and helpful to rotate crops. So perhaps you identify areas that are higher and you change your rotation plan to, in that area, only include plants or only rotate plants that have a relatively low propensity to take up PFAS. So these are real applications that we can provide farmers, and that's the purpose of a lot of this data. However, there is also year-to-year variability in uptake with certain crops especially, and we are still not certain which factors we need to explore or which factors might be contributing to that variation in uptake. There's some research out on perennial grasses that suggests that it's probably not pH or cation exchange capacity or I'm sorry, it may be weather, so variation in weather. There is also some research suggesting that organic matter might have something to do with binding PFAS in the soil, so preventing that uptake. However, we need larger and more sufficient data sets so that we can help farmers manage their land and their crops to reduce or eliminate uptake. And that's the key takeaway, I think, for regulators and scientists and the research community, is that we need to see more field studies. A lot of the work in the literature is greenhouse or potted plant studies using spiked soil, and doesn't address the variability that we're seeing in these opportunistic field studies. So we need more scientists in the field doing that research to really pin down what are those contributing factors. Once again, really special thanks to the Maine CDC, Dr. Andy Smith and Tom Simmons, as well as my colleagues at the DEP and of course the PFAS Response Program, PFAS Fund, but most importantly, very special thank you to all the farmers, homesteaders, and landowners that willingly provided their time and their land to allow us to conduct this work. It was something they did at the risk of their livelihood, and I think that's really important to recognize and to end on. And before we go to questions, one last slide. These are some additional, this is some additional research. This will be on the PDF if you need to refer to it later. Both of these articles came out this year from Maine, one very, very recently, led by Dr. Simmons at the Maine CDC, as well as a lot of folks from DEP, MOFGA, UMaine, FDA, so a lot of collaboration there. And then the second one is actually research done by a master's student at the University of Maine who's now going to be pursuing their PhD at the University of Maine, looking at drivers of plant uptake in agricultural fields. And with that, I'll take any questions.
Excellent. Well, thank you so much, Duncan, for that detail. So a basic question that people have is about the soil sampling. What's the recommended, interval or depth that you're taking your samples and you're doing the compositing and that sort of thing? That Mary or Duncan can answer that one.
Yeah, that's a great question. So and I'm going to turn my camera on so I can talk to you guys. So we have been sampling soil generally in the 6 to 8 inch range. So looking at the top 6 to 8 inches, specifically with vegetables. We do that primarily because the vast majority of plant roots that are interacting with the soil are found in that 6 to 8 inch range. The one exception is with the asparagus that we sampled, because asparagus is very well known to have, because it's a perennial crop, very well known to have a very extensive root system, sometimes reaching down 10 to 15 feet in the soil. So we did go 12 to 13 inches down to collect the soil from those asparagus plots.
Okay. Here's a question again for both of you or either one of you. What does it mean to a farmer to adjust? I think that's maybe switching to different crops or something, but we can talk about that. And then continue with technical and financial support. So, you know, how long are you interacting with the farmer? And then what kinds of programs are in place? What are their goals and how are they funded? I think you've talked a little bit about that, but.
Yeah, so I think Mary hit on a lot of that in her presentation. As far as what does it mean to the farmer, it really depends on the farmer and depends on our relationship with the farmer. There are some farms where pivoting to an alternative crop or to a different product or moving part of their production to another area of their farm is very easy. And we're able to make that suggestion. They go through with it and we see a decrease, and that's a great success. There are other farms where the land base is much more limited or more contaminated, and it's much more difficult for that farmer to perhaps pivot or use a different part of the farm. So it really depends on the farm itself. Depends on what they're producing, depends on what sort of soil concentrations we're looking at. However, there is a lot of support in Maine, and when I say a lot, I mean like $70 million worth of support in Maine, both with the PFAS fund and the PFAS response program to test soil for farmers where there's concern, to pay farmers for their time. So we actually provide up to $3,500 to farmers just for working with us, because we recognize that that is time away from their job and their livelihood that they have to talk and deal with us. We also provide infrastructure grants. I believe the response program, the infrastructure grants cap at about 150,000, and then the PFAS fund will deal with infrastructure grants even greater than that. So, you know, if we're looking at buying farm equipment, or if someone's looking at buying farm equipment, if that's the recommendation we make, sometimes a single piece of equipment like a combine can cost several $100,000. It's very expensive. It's not something that a farm can kind of just do on a whim. And so we recognize that and we work with them. And then the time frame really varies too. Some of these farms we've been working with since 2022. There are other farms that we, especially this summer, we went out and sampled some sites that we were concerned about. We found that they had levels that were background levels, and it was very, you know, kind of a one and done situation. We sampled the soil. We weren't concerned about the soil levels at all. And we said, you know, we wouldn't recommend any change to how you're doing things. We don't think that these levels are concerning for human health. And Mary, I don't know if you have anything to add, but there's a lot in Mary's presentation if you want to review that.
So you just talked about human health. So is there a correlation between the contamination level in the vegetable and what, you know, ends up being absorbed or that humans end up with?
I'm going to repeat that back because okay, so we're talking about, now we're moving from soil to plant to human. Is that the question?
Yeah.
So I'm definitely not qualified to answer that question, but whoever has asked it is more than welcome to contact the Maine CDC toxicologists. They deal with all of the human health related questions for PFAS, and they're more than happy to consult with individuals, farm owners, homesteaders who are concerned about their exposure from a human health perspective. But I don't think it'd be appropriate for me to answer that because I'm not a toxicologist or a health professional.
Okay. How about, are you testing for a lot of different PFAS compounds in the soil and in the crops and the animals, or just a small subset? Or are you doing any total organic fluorine or top assay or any of that kind of stuff?
So we are sampling for various PFAS compounds. When we were using the modified isotope dilution methods, I believe we're getting about 20 to 30 compounds in that mix. I think now with 1633, I'm not sure how many compounds they measure there, maybe something like maybe 16 to 40, something like that. I'd have to look back at a lab report to tell you that information. It's also available online. We're not just measuring PFAS, but we are also not doing top assays, and we're not measuring total organic fluorine. We're looking specifically for the PFAS that we are most concerned about, which at this point is really just PFOS when we're looking in food products. There is some work that we are doing on PFNA and PFDA in milk and beef, but I don't think we have enough data on that to give any recommendations.
Mm-hmm. I'm looking at a report from Maine Labs, EPA method 1633. It looks like 44 compounds.
So 44, yeah. Yeah, and so that would include your fluorotelomeres, some of them, your FTSs, which I know there's a lot of interest with precursors. It's something we've kind of poked at a little bit, but there's no tox value for precursors, so we can't really do much with that as far as developing an action level.
Mm-hmm. Okay, here's a question about like the drinking water near some of these farms. If the soil has high levels, or I guess you found sometimes the crops or the animals, it's the water that is being used and not necessarily the soil that's the issue. So what's the correlation between the work with soil and the work with water?
Yeah. So yes, there are some instances where the exposure pathway is primarily from contaminated irrigation water. So either animals are drinking contaminated water, or farmers are spraying their crops with contaminated water as a source to water them. It is much more difficult in conversations we've had with CDC. It is much more difficult for them to do the sort of work to model concern when it comes to an irrigation pathway. I am not sure exactly the specifics or what is difficult about that, but we have asked them about certain levels in water, and should we be concerned, should we not? And I think the easiest answer is that if you have PFAS above the advice that we give farmers, if they have PFAS above the current drinking water standard in Maine, we suggest filtering that. If they're using that for crops or animals, that's our suggestion in most cases. Now, if we have evidence that it's not affecting that crop or that animal, then we don't see a reason that they should spend the additional funds to install a filter. But in cases where it's like a really high level, we would recommend filtering that water source.
All right, well, we're pushing up on 3, but I'll ask one more sort of combined question, perhaps for Mary.
Sure.
So what is the process if a farmer, you know, they did apply sludge or biosolids to their field, but they don't agree to sampling? So is there any sort of process there? And then the farms that have ceased operation, was that voluntary, or was some like deed restriction or covenant put on, you know, was there any regulatory action taken?
Well, I can answer the first. I understand the first question. So at the moment, we are not, you know, forcing anyone to submit to sampling. We have a permission form that we ask landowners. We want landowners to sign that and make sure they understand what they're permitting. And if they don't sign it, we don't sample. At some future point, perhaps that may change, but that's what the situation is right now. The same is true for DEP. And I'm not sure I understand the second part of that question.
So I think you said some of the farms have ceased operation, and was that voluntary, or were they sort of because the levels were at some sort of levels that there had to be some regulatory action taken?
It's a combination. Some farms have voluntarily decided that they are done and wanted to move on and off the site. Other farms, because of, you know, exceeding action levels and just the nature of the contamination on the farm, and, you know, and what they are able to, the type of farming they're able to do, they have to cease operations or pare it back to something else. So, you know, we have livestock farmers who perhaps are now haying, and maybe not the contaminated fields, but other fields that are not contaminated, and no longer doing the livestock aspect because of contamination. Duncan, do you have any other examples, or I think that it's a combination?
Yeah, it is a combination. Our adulteration orders have not to this date put a farm out of business. It has never been the sole reason that a farm is not operating. Farmers have voluntarily ceased operation and moved their operations elsewhere. And then there have been issues with just the economics of farming being very difficult, and this kind of being the straw that broke the camel's back.
I mean, I have heard rumors on the streets, you know, like the state is seizing farms. That is not true. Yeah, because of PFAS contamination, definitely not.
All right, well, I think I've gone through most of the questions, most of the topics, and we are a little bit after 3. So with that, I think we will just end. And I just really want to thank Duncan and Mary for their excellent presentations, and just the state of Maine for all the great work that they're doing up there, and what a resource for others. So I think the slides will be posted on the NMOA website, and Duncan and Mary both had their contact information, I think, in their slides, as well as Duncan had some other resources, some papers to link to, so so folks can follow up with Duncan and Mary later. And again, just thank you so much, and I hope everybody enjoys the rest of their day.
Thank you,
with
Jennifer.
That, bye, folks.
Thank you, Jennifer. Have a good one.
Bye.
You too.